Planet Earth, seen from space. A sight enjoyed firsthand by fewer than 600 people. For the astronauts in the International Space Station, it's a tantalizing vision of a world out of reach. A familiar and inviting world with a promise of freedom and escape from confinement. But imagine spending 7 months floating in a tin can and returning to a completely different planet. Down here on the Earth's surface, we're still under lockdown. But I'll be speaking to astronaut Jessica Meir on her rather unusual return to a planet she barely recognised.
We've got news of the closest black hole yet discovered. And Lucy Green has been looking at how Elon Musk's Starlink satellites are changing our views of the night sky. Welcome to the Sky at Night.
Come again. We are sending.
On the 17th of April, Jessica Meir, along with fellow astronaut Andrew Morgan and cosmonaut Oleg Skoropaczka, left the International Space Station and fell down to Earth. But the planet she returned to was not the same as the one she left behind 7 months before. First of all, I'd just like to say welcome back to Earth, and my apologies because we made a bit of a mess while you were gone.
Yeah, no kidding.
Your journey home was not the standard journey home. It must have been quite different. What happened?
It was, I think even just from the very first moments as we were leaving the space station and realizing that we were absolutely returning to a completely different planet than the one that we left, we were trying to mentally prepare ourselves for that. But, during the actual descent itself, you're pretty focused on the dynamic event that you're going through, re-entering the atmosphere and everything. But as soon as the hatch opened and the search and rescue teams were there waiting for us, that was our first exposure to a whole group of masked people.
But what happened when you got back to Houston? Could you go and see people, or you again in lockdown?
Well, normally astronauts will spend maybe one night in the quarantine facility at NASA, but for us, they actually had us stay for a full week because one of the hallmarks of spaceflight is a dysregulation of the immune system. There's something going on with the immune system and its response to the microgravity, the space environment that is causing these changes, which are quite common in astronauts.
It must have been very odd to hear about COVID-19, but to look at it from afar from the International Space Station.
It was very odd, and actually it felt quite surreal. Our days were unaffected. We were very busy up there carrying out our mission objectives, and that is really a testament to the ground teams, because on the ground, of course, everybody's lives were affected. And that was the part that made it so surreal. We were up there, just 3 humans, thinking we are the only 3 humans right now that are unaffected by this virus. It's truly a pandemic. It's truly global. I mean, it seemed like it was the start of some kind of sci-fi disaster movie, with the 3 astronauts on board, seeing everything happen.
But you've been back for about 6 weeks now, and you've gone from the sort of isolation of the International Space Station to lockdown at home. How are you adjusting to that?
Yeah, it's interesting. I think the isolation and confinement, I feel that more here on the ground than I did actually in space. And I think that's because in space, that's expected. It's part of our mission, and it's for a good reason. When we look out the window, we know that we cannot physically survive in the vacuum of space without a spacesuit or a spacecraft. And so there's a reason why we are so isolated in space. But our society here on Earth is not built that way. We're not supposed to be isolated to one spot. And as humans, we crave those interactions and really need those in order to survive and to thrive.
So yes, while you're on the space station, what were your missions? What were your scientific objectives?
It is extraordinary as a scientist up there because you get to dabble in everything, all these cool things. So we were doing experiments ranging from physiology and medicine, so understanding how spaceflight and the microgravity environment affect the human body. We do combustion science, even flames burn differently in space. There's pharmaceutical research, so we're growing protein crystals. You can grow bigger and more pure crystals in microgravity. So there's really just a huge variety of all types of science represented, and that's what keeps it so exciting for us.
Now, your spacewalk. My dream is to go and look at planet Earth unencumbered by a window or anything. What was it like?
Well, that was my dream too. Really, when you're out there, the only thing that is separating the vacuum of space is that thin visor in front of you. The colors are just a little bit more vivid, and it's just even more real. And the first time I came out of the hatch, looking down and seeing my boots and then nothing else but the Earth below, I mean, it's quite difficult to believe that it's actually taking place.
Jessica's first spacewalk was a 7-hour marathon, replacing a faulty battery unit.
And you're clear of it now. Okay, great.
But what made it truly notable and attracted global attention was this was the first ever all-female spacewalk, carried out with fellow astronaut Christina Cook.
Hey, Anna, I'm right behind you. All right.
For Christina and I, it was something so special, but that was actually almost a bit overwhelming for me to see the response, the enthusiasm and the excitement, and how inspired people were personally.
You ready for me to start heading up? Okay, I'm clear of the wagon wheel area.
And that was really quite humbling. And it's not so much anything to do with our achievements, but it really is a testament to the generations of women and everybody that worked so hard pushing the envelope and breaking down those barriers.
Happy, thank you. Congratulations.
Because those barriers were certainly there. We didn't have a seat at the table at all times. And now I am lucky enough to be on the side that benefits from it.
Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
So we just had the launch to the ISS with SpaceX. Looking at the commercial aspect of that, do you think there's hopes for the likes of me to get out there soon?
I hope so. This is a really exciting time where we're going to have multiple vehicles to get humans to space.
Dragon separation confirmed.
That also frees up resources at NASA for us to be able to focus on longer term and longer range exploration programs when we go back to the moon and eventually onto Mars.
Well, thank you so much for talking to us.
All right, thank you so much. Great speaking to you today. Take care.
Love to speak to you. Take care.
Last year, we were in Washington, D.C. for the unveiling of a remarkable image from the Event Horizon Telescope, showing the shadow of a black hole. The Event Horizon team have been busy releasing these new images of activity around a growing black hole in galaxy 3C279. The material falling in is disturbed and heated, even forming a jet. And we often detect black holes precisely because of this kind of activity.
But what is a black hole anyway?
Black holes exist because of gravity. The more massive and dense an object is, the harder it is to escape from its gravitational pull. So standing here on Earth, for example, I'd have to jump at about 25,000 miles per hour to escape from the planet. If I took all of the Earth and crushed it to a smaller sphere, then I'd have to work even harder to get away. If I took all of the Earth's mass and I reduced it to a sphere just 1 centimetre across, then nothing could escape, not even light, the fastest thing in the universe. I'd have created a black hole, an object cut off from the rest of the universe. Once you fall in, you could never escape. These fascinating objects never cease to surprise, and just a few weeks ago, a team of astronomers announced the discovery of the nearest black hole to Earth, just 1,000 light years away. The discovery was an accident, as is so often the case in science. It came about as the astronomers were studying a curious binary star system that's actually bright enough to be visible with the naked eye, as long as you're in the southern hemisphere. It consists of 2 stars locked in orbit around each other. And it was some strange irregularities in their movement that led to an inevitable deduction. I talked to the astronomer who led the research, Thomas Ravinius, from his home in Chile. Well, thank you for talking to us. I think this discovery is really exciting. Can you start by telling us why were you looking at this star system in the first place?
Well, thank you much for having me. Looking at that star was triggered basically by the fact that it's rotating very rapidly, so much that it's actually not spherical but oblate in shape, and the matter is flowing off on the equator by itself. And there were two stars, we knew that. So we were looking why there was a difference. So one is rotating rapidly, one is rotating slowly, and we were trying to understand the difference.
So it's a sort of interesting cosmic mystery in itself.
Well, it would have been if there was not something else. When we were looking at it, then we noticed early on there should be a third object.
So what was it about the two stars that you could observe that told you there was something else there?
It's basically a very similar method as you do to find planets. You look at the wobble of the star as it moves back and forth. They should have a coordinated wobble. One should go back, one should go forth. However, it wasn't the case. One was moving back and forth, as you would have expected, and the other wasn't moving at all. And this told us that it cannot be the counterpart of that wobble, so there must be something else.
So that told us that there was something there. What tells us that it's a black hole?
In the beginning, we thought it might be something boring, uninteresting, like a faint star. When you inject the parameters of the wobble, the speed and the time, into basically Kepler's and Newton's laws, you get the smallest possible mass this object can have. And with that smallest possible mass, we were looking what it could be. If it could be a star, it needs to have a certain brightness. A star with that mass just needs to have a certain brightness. It can't be any fainter. And then we concluded that if it was a star, we should have seen it. And so if it's not seen, it must be something dark. But something dark with that mass, it can only be a black hole.
So was it surprising to find a black hole just 1,000 light years away?
It is surprising in the aspect that black holes are very hard to find, in particular if they are not producing X-rays. In terms of how many black holes there are, it is not, because black holes are rather common objects. They are just incredibly hard to find.
Thomas estimates that there could be up to 1 billion of them in our galaxy. As matter falls towards a black hole, it heats up and shines brightly in X-rays. And that's how we normally find them. But this black hole is producing no X-rays, meaning it's a very black hole, and especially hard to spot.
This black hole is not accreting anything, and you really only see it through its gravitational interaction with the other stars that are around.
Does having a black hole in the system solve the mystery of the rotation of the stars?
No, not really. That is, we are still wondering why these stars rotate so fast.
It's kind of nice that the original mystery is still there. Even though you sort of published the paper and announced there was this black hole there, you've still got the same problem you started with.
Yes, that's...
So this is a naked eye star. You can see this. Have you been out and looked?
Not yet, because at the time when I realized it was what it was behind the sun.
Ah.
And right now it's just coming up as a morning object.
Okay. I think you should go out and look at it. I think you should just nod in a satisfied way at it and know that there's a black hole there.
At the latest, when the observatories reopen and we go back there.
Good luck with the reopening, and thank you for taking the time to talk to us. It's fascinating.
Thank you. Bye.
If it wasn't for lockdown, we'd probably send Pete to the southern hemisphere to see if he could photograph Thomas's black hole system. But instead, he's here in the northern hemisphere.
Hello, welcome back to my garden. Well, it's been cloudy all day, but there is a sort of line of clear weather which does appear to be coming up. And if I'm really lucky, I might catch a glimpse of Mercury before it sets. I'll catch Venus, and I've been trying to look at the night side of Venus. So fingers crossed. I'm just trying to see whether I can see Mercury down there with the naked eye. Can I see it? No. Okay, I've managed to get Venus in the field of view now. It's showing a beautiful crescent. Let me show you the crescent. As it's getting close to the sun, the crescent's getting really thin. Well, that wobbliness, the bubbling you can see there, is just due to the Earth's atmosphere. But that crescent is just glorious, isn't it? It can be quite difficult looking for Mercury in the twilight sky. But it is, oh, I've got it, there it is, just above the tree down there. I should be able to get it with a camera. Yeah, oh yeah, there it is. It's very faint. Okay, so I've managed to get a shot of Mercury. I'm just going to try and show you how small it is. So basically, if I zoom in, there we go. So if I zoom out again, you'll see just how tiny that is. Not many people have seen Mercury. It's a tricky little planet. Okay, so the sun has gone a little bit below the horizon now, and I've got Venus in the telescope at the moment, and I'm going to try and take a picture of the night side. When we look at a crescent moon, we can still just see the night side, faintly illuminated by sunlight bouncing off the Earth, Earthshine. But Venus is far too distant to be lit by any reflected Earthlight. As a result, the night side of a crescent Venus is completely black. But that doesn't mean we can't see it. We just have to look for the heat generated from deep within the planet. Heat that makes the surface glow in the infrared. So this is a camera which is very sensitive to the infrared part of the spectrum. So I'm now going to completely overexpose the crescent, and that's giving me a bloated version of the crescent. I don't know if you can see that. Let me bring that in for you. I'm just going to finish processing this, see whether I can bring out the night side a bit clearer. Oh yeah, there it is. That looks pretty good actually. Yeah, you can definitely see it there. That's quite good. Illuminated only by the planet's inner heat, you can just make out the night side of Venus. And that's quite something. And there's one last heavenly body I want to catch tonight, the International Space Station. Okay, yeah, I've got about 5 minutes before the ISS comes over, so I'm cutting it a little bit fine. So I'll use a wide-angle lens for this. I always put that on the wrong way around. Now I've got an app on my phone which actually shows me where the ISS is going to go relative to the stars. So it's going to pass through the top of Leo, almost overhead actually, which is pretty good. Relatively low ISO, f8, and then we'll just give that a go. But I think I need to get my act together now because I can see the ISS coming up over there. Flying by the seat of your pants, really. I don't know if you can actually pick it up with that camera. It'd be nice if you could. I'll angle you back a bit so you're looking up at the sky. There we go. It's now passing a star called Algebra, which is a lovely double star if you look at it with a telescope. Amazing to think there are people up there.
Satellite spotting's got a lot easier recently, with the launch of a new constellation of satellites known as Starlink, which is growing rapidly. With thousands more launches planned, our night sky might soon look completely different.
Falcon 9 and startup.
Gyros close-up. Complete.
LDs go for launch.
T-minus 15 seconds.
I never get tired of seeing a launch. Earlier this year I was over in Florida to see the Solar Orbiter spacecraft go, and it was a spectacular night launch. The sound and the sight is something I will never forget. Now this particular rocket is carrying up 60 Starlink satellites into orbit around the Earth. If the launch happens at just the right time, when the sun is over our horizon but it's not yet fully dark, then you can head outside 15 or so minutes later and see the newly launched spacecraft fresh from hurtling across the Atlantic. The satellites form a series of bright separated dots in the sky. one after the other, coming over like a string of pearls. It's an astonishing sight, akin to a sci-fi movie. It is a totally different sky. The idea of Starlink is to provide a broadband network that spans the globe. So far, just under 500 satellites have been launched. But in the coming years, this will expand to a vast network of 12,000, covering the entire planet. Like everything Elon Musk does, it's not without controversy, but yet it's trailblazing and audacious at the same time. If we're to believe what SpaceX says, then these satellites could bring easy, accessible broadband around the world, potentially revolutionising people's lives. But for astronomers, it potentially ruins our night skies, and once started, could be irreversible. And as a space scientist, it's something that I often think about, and I often talk about over lunch with my colleague, Richard Cole. Hello.
Hi there, Lucy.
Long time no see. What benefits are we going to get?
We know they're going to provide internet service of some sort to somebody, but exactly what and when is not clear. And the only deals that have been made public are with the US Air Force and US Army.
So actually that's making me think a bit more cynically. The military applications first actually maybe changes what we might be willing to put up with in terms of this sort of new form of light pollution.
I think in terms of amateur astronomy, then I guess these will just be a bit of a pest. In terms of professional astronomy, that's not so good.
I've been gathering information from astronomers who are directly affected. One group for whom this might pose a real risk is astronomers who are using wide-field telescopes to search for asteroids and comets.
We're concerned about the impact of the Starlink system affecting our ability to discover new asteroids and comets out there. We generally take 4 exposures of the same part of the night sky and look for the object moving against the background. If one of those images is compromised by a satellite trail, we should still be able to detect that new object from the remaining 3 exposures, but the accuracy with which we can predict where that object is going initially will be greatly reduced.
I'm deeply concerned about the influence of Starlink satellites on dark night skies. I work on the Vera-Rubin Observatory, this gigantic telescope that's about to start taking images of the dark night sky every few nights over 10 years. About 30% or potentially even more of our images will be contaminated by Starlink satellite trails, potentially even ruined.
This is a representation of a Starlink spacecraft.
Hold it up just slightly more. Oh, looks like a chocolate bar.
As soon as it comes out of the launcher, then it pings out on the way up to orbit, up to the final orbit. They're actually folded out like this. This whole thing is about 8 or 10 metres long and about 2 metres wide. It's a really big area, so it's not surprising they're so bright.
That's when I've seen them. That's when I've been out and just watched one after another
That's
go over. I found it astonishing to look at the spacecraft, but it's the implication of what it means when we've got many more of them up there.
Yes.
Then, of course, there's our stargazing community.
It's going to sort of scribble all over something which is a very beautiful natural resource. And I think that's a bit sad, really. It's sort of trashing something which I've grown up with, something of great beauty. It would have been nice if a little bit of consideration had been given to the population of the planet.
And the issue of cluttering up space is a real one. There's actually not as much space up there as you might think.
I've been looking at the implications of releasing large numbers of satellites into low Earth orbit, a region that is quite widely used by every other spacecraft. And that's quite possibly going to introduce some problems in terms of potential collisions that might occur. Quite recently, a European Space Agency satellite and a Starlink satellite, they got quite close together, and the ESA satellite had to make a maneuver to avoid a potential collision. So I think we're going to see much more of those events taking place in the future.
And then there are those astronomers who are using our larger telescopes to peer deep into space.
12,000 is a huge number, and if you think that there are only a few thousand stars visible with the naked eye in the sky, it looks frightening. Once the satellites reach their final orbit, they will be at the limit of what you can see with the naked eye. But that is still very bright for a telescope.
I went out a few nights ago. I thought, I'll just look at Starlinks. And I just moved from one to the other, 1, 2,
How many did you see?
3, 4. Oh, about 10 or 15 in about 10 minutes. I mean, they were always there.
If they cross the field of view of your telescope, they're going to cause trouble. And for a telescope like the Very Large Telescope at ESO, we computed that we are going to lose between 1 and 3% of the exposures during twilight. We are not particularly happy about it, but it's not the end of the world.
Do you think SpaceX have been, suitably engaged in trying to mitigate the effect of these satellites?
I think they have been, but really after the event, Elon Musk has said, if there's a problem, he'll solve it. I mean, okay, well, we'll see what he does. Yeah.
That's a bold promise, but that I'm happy to hear.
The people at Starlink are extremely responsive. Once they understood exactly what the problem is, they proposed some solutions. They're trying really hard to make the satellites darker by painting, to make it as dark as possible. But there are some limits. The Starlink engineers have come up with another idea, which is to build a visor to shield the body of the satellite from the sun.
Panels will flap down and they will cast a shadow onto this panel over the bright bits.
So it is literally like having a sun visor. So are the changes being made to the Starlink satellites likely to make any difference?
We are really anxious to see these developments because it could really be a game changer.
There's no way you can hide those satellites from our sensitive telescopes and cameras. And until we're sure of exactly what the effect is going to be, we remain concerned.
What they are doing is legal. We have to live with them.
I see the night sky as a site of special scientific interest. That's how I classify it. And so it should be looked after. It should be for everybody to enjoy. And part of that is the utilisation of space because it brings benefits to our lives. So, with no international regulations in place, we're left with the question, who owns the night sky?
Who owns the night sky?
I'm an astronomer, I'm not a space lawyer.
I think of the night sky as another sort of place of natural beauty. It is like a waterfall or a national park.
We all get a joy of looking up on a dark night and looking at the stars, the planets, the Milky Way, and we don't want that view ruined.
We don't have a light pollution rule at the UN, and I think that's what we need to change.
Who owns the night sky?
My gut reaction is I'd love to say everyone.
We all do. Anyone who's ever looked up in wonder, anyone who ever will look up, has a stake in it.
I think we all own the night sky.
The public, the world, everyone owns the night sky.
It belongs to all of us to enjoy, become inspired by.
Next month, we're focusing on the lives of stars.
Until then.
Good night.
Moment by moment, the extraordinary mission that took the giant leap. 8 days to the moon and back, streaming now on BBC iPlayer. Here next, BBC4's Culture in Quarantine, bringing exceptional theatre to your home. Christopher Eccleston and Niamh Cusack in Macbeth.